Let us now look at topography that is associated with inclined strata. We looked at topography that was associated with horizontal strata, and in this one we're going to be looking at inclined strata. So let's look at the homoclinal ridges that we find within the Magaliesberg range. Those homoclinal ridges consist of cap rocks that represent resistant rock, and then they have gently dipping slopes and steep scarp slopes. And so those are the features that are associated with a homoclinal ridge. So a homoclinal ridge is a number of hills that have the similar angle, and that's why they're called homoclinal. They've got the same angle of dip. Now let's look at this more carefully, and we look at what we see within the Magaliesberg range. We see a number of hills dipping like that, and we get dipping strata producing a cuesta, and development happens between those ridges. But now let's look carefully at the cuesta. Can you see the cuesta has got a steeper scarp slope and a gentle dipping slope? And can you see why it's called a dip slope? Because that represents the layers that have are dipping or tilted, and so that is why that slope is called the dip slope. And sometimes, usually, the top of the dip slope might then have your resistant cap rock. Another feature that is associated with dipping strata would be similar to the cuesta, but it has a steeper dipping slope. And so that kind of feature then is called a hogsback. So the difference between a cuesta and a hogsback is that a cuesta has a gentle dipping slope, whereas a hogsback has a steeper slope. And as with the horizontal strata, we also get different slope elements that occur here, and we get the same elements that we get with horizontal strata. So we get a crest, we get a cliff, we get a talus, and a pediment. So the slope elements are the same as what we would then get with horizontal strata. Let's now look at the Magaliesberg from a topographic map point of view. Can you see there are the homoclinal ridges, and you see how they are lying like that with the dip to the north? And notice how they've influenced land use, in that now the roads have to run parallel to the ridges and can only pass through the mountain where there's a gap. And notice how along the dip cultivation happens. So can you see how when we look at these layers, they then have an impact on human use of the land because of the dipping of the homoclinal ridges. Now let's look at it in block diagram. There we see the homoclinal ridges, there we see the dip slopes, and then we see on the other side the scarp slopes, and so there we see the features that are associated with homoclinal ridges. And now let's look at a Google image and put the contour lines over that, and notice now what it shows. It shows your dip slope, your scarp slope, and notice how settlement then develops there along the pediment of the scarp slope, because that area is now level, and so settlement, people could build homes there, and also they could cultivate those areas as you saw on the topographic map.